Hi, myself Manjunath from the Department of Electrical and Electronics Engineering of KLSVD IT Haliyal welcomes everyone for this session on the subject testing and commissioning of power system apparatus, which is an lecture for the 7th semester having the subject code of 17EE752. In the previous sessions, we had the topics like need of testing of an induction motor. It is always essential to test all the electrical equipment, not only induction motor, to check its ability whether or not it gives the performance according to standard design conditions or not. That's why the testing of any electrical equipment as well as the induction motor is essential, what you have learned. Afterwards, we have seen the test like a load test that is conducted on the induction motor as per the standards given by the manufacturer as well as the Indian standards. In that test, we try to determine the efficiency, the slip and the torque at which the particular induction motor will be operating at the different load conditions. Then afterwards, we have gone through a no load test. In that case, we have found out the no load current as well as the no load power factor as well as the core losses that exist in case of a induction motor when it is operated at particular no load condition. That test is also called as rated voltage test. Then afterwards, we came to know about how to determine the power factor by different methods, that is load test. In case of load test, we had the 2 wattmeter reading. Those 2 wattmeter readings can be considered for the determination of power factor, and directly wattage consumed by the induction motor can be directly used to determine the power factor at which the particular induction motor will be operating, and that what we have seen in the previous session. Now in this session, we're going to have the other two tests, what you call it, the blocked rotor test. It is also called as rated current test, from which you're going to find out the copper losses that exist in case of the induction motor when it is operated under blocked rotor condition. Then afterwards, we're going to moving on to the high voltage test. It is always essential to check the ability of insulation, whether it can withstand the applied the voltage under high voltage test as per the standard. Then afterwards, it is always essential to have the proper maintenance, to have the proper operational activities from an induction motor. That's why the overhauling as well as the maintenance comes into picture. Now we'll go one by one before going to those tests. What are the learning objectives after the class? The student should be in a position to explain the meaning of the block rotor test and how it can be conducted. What are the parameters we get and he gets from the block rotor test? Then he should be in a position to explain why high voltage test is essential, how it can be conducted. Then why the maintenance is required and the meaning of overhauling. He should explain everything about why it is essential to overhaul or maybe requirement of the maintenance for an induction motor. This is about the learning outcomes. Now let us go one by one. First we can go for a testing of an induction motor. This test is conducted in accordance to the standards given by Indian standards as well as the manufacturer guidelines. Indian standard for testing of an induction motor for its lock rotor test is 4029. In this case, before conducting the experiment, induction motor rotor is locked with the help of a brake drum arrangement, and the 2 wattmeters are connected as shown in the figure with the amateurs in series one of the line and voltmeter across the 2 line terminals. And all this complete setup is connected via or through the auto transformer, 3-phase at the auto transformer. The test is also called as the rated current test, in which I am going to apply the small voltage around 10 to 20% voltage until this ammeter shows a rated current, or according to the standard for particular the capacity of induction motor specified by 4029. It is a simple experiment to determine the copper losses in an induction motor at a particular value of the state current. The procedure is simple. After making the connections, we are going to apply the reduce the supply voltage until this meter shows the short circuit rated current. Once it shows the voltmeter reading, the ammeter reading, and the 2 wattmeter readings are taken, and the algebraic sum of 2 wattmeter is taken as a WSC. This provides the copper losses in an induction motor at the particular short circuit current. Now, by knowing all this meter reading, I can find out the power factor at which the induction motor will be operating under short circuit conditions. This is about the locked rotor test, which is conducted according to standards of 4029. Now, next we will move on to the determination of a slip. The slip of an induction motor is determined according to the standards what is given here, 7029 of 1967. The standard that is used for determination of a slip of an induction motor is 7029. There are 4 methods are available. Among that one, first method is with the help of the speed measurement. In this case, first of all, we are supposed to find out the synchronous speed at which the induction motor will be operating. The synchronous speed is given by the equation 120 F by P, where F is the frequency of the supply, then P is the number of poles. Then, in this method, with the help of a load test or any other test, we can determine the speed at which the induction motor rotates, that is considered to be as value of n, that is at any load condition it will be operating at the specific speed that will be taken as n. Then knowing the synchronous speed as well the rotational speed of an induction motor at a different load condition, we can find out the slip at which the induction motor will be in operation, that is given by ns minus n into 100 divided by the ns. This is the first method how we can determine the slip of the induction motor. Next one, we go for a slip coil method. In case of this one, a coil approximately 700 number of turns having the diameter of 2 mm insulated wire is passed axially over the motor. I consider the 700 numbers of turns insulated wire of 2 mm diameter, and I'll wind it axially over the motor, and the 2 ends of the particular coil is brought outside, connected to the galvanometer having the center zero. Once it is connected, the motor is started, and during the running of an induction motor, the galvanometer will oscillate either towards the left of 0 or maybe right of 0. Therefore, during this process, a number of oscillations of the galvanometer are counted either left of 0 or right of 0 for a period of 20 seconds. Then, after knowing the number of oscillation either towards the left side or maybe right side of the center zero galvanometer for a particular specified time, the percentage slip can be determined with the help of this equation, that is equals to n into 100 divided by t into f, where n is the number of oscillation what we have counted either towards the left of 0 or maybe right of 0, and the t is a time period for which that particular oscillations are counted either towards the left of 0 or maybe right of 0, and f is the frequency of the supply. Accordingly, that slip of the induction motor is determined. Third method is a magnetic needle method. It is a similar the way in which the second method was conducted. In case of this one, we take a magnetic needle, suspend it on the sharp needle we take a magnetic needle, we suspend that on a sharp needle and free to rotate and place an induction motor body in the horizontal plane. We take a magnetic needle, suspend over the sharp needle and keep it on the induction motor in the horizontal plane. Then the motor is started. Once the motor gets started, the magnetic needle will oscillate. Magnetic needle will oscillate. That the oscillations, or maybe those oscillations, are counted in a, or maybe for a period of the specific time period. It depends on 20 seconds or 30 seconds, that will be counted as t seconds. Therefore, the number of oscillations of a magnetic needle when the motor is under running condition are counted, and the percentage slip can be determined with the help of this equation n into 100 divided by t into f, where once again n is the number of oscillations of the magnetic needle into 100, and t is the time over which the particular number of n oscillations are counted, and f becomes the frequency of the supply. This is the third method. It is similar to the second method, that is the slip coil method. That is a simple method. Once again, the same equations that are used in both the slip coil method as well as the magnetic needle method, both are same, wherein which you are going to count the number of oscillations in a specific time period t. That is, time period is not fixed. We can have a 5 seconds or a 10 seconds or a 20 seconds, depends upon your convenience. That is, those number of oscillations are counted and the substituted in the particular equation, that is this equation, and you can find out the percentage slip. These are the three methods. The fourth method is by the rotor frequency oscillation method. Here I am going to have a moving coil ammeter with a center 0 will be inserted in the rotor of an induction motor. Then afterwards, the number of oscillations are counted by a pointer of an ammeter. Then the percentage slip equals to rotor frequency into 100 by a stator frequency, which gives the percentage slip. This is about the fourth method of determining the percentage slip. After knowing the four methods of determining the slip percentage as a percentage slip, let us move on to the next test, which is very much important for an induction motor or maybe any electrical equipment. It is called as high voltage test, which is called as high voltage test. In this test, we are going to apply the specific voltage across the terminals across which you are supposed to determine its insulation withstanding ability. That's why we call this one a high voltage test. This test is conducted in accordance to the standards, the 4029 of 1967. This test is conducted in high voltage testing laboratory only. I cannot conduct this test anywhere, anytime as such. Only it has to be conducted in the standard testing laboratories where the generation of high voltage will be there. And here the specified voltage in accordance to standards of 4029 is applied across the terminals whose withstanding ability is to be determined. Here from this one, you're going to check out the ability of an insulation, whether or not it can withstand the specified voltage which is applied across this one. This test is conducted, as I said already, in the testing laboratory. This is done to check the ability of insulation, whether or not it can withstand the applied high voltage as per the standards. That is, the block diagram which is required for this one, it will be shown in the next slide. The motor which is to be tested connected as in the figure, the next slide. The three terminals, that is three terminals, I'll short it, stator winding which are brought outside, are shorted and connected to HT terminal of the HV transformer. Other, that is the ground terminal of the high voltage transformer, as well as the protective coating and protective casing of induction motor are grounded together, and voltage we are going to apply between the shorter terminals, that is to the high voltage terminal, as well as the ground terminal will be applied to check the ability of insulation. You can see that circuit diagram, that is we require single phase supply, and we are going to apply the voltage variation from 0 to 230 to the high voltage transformer, which can vary the voltage from 0 to 60 kV or maybe 0 to 150 kV. It depends upon the high voltage transformer capacity. High voltage transformer capacity. You can see that all the three terminals shorted and connected to HT terminal of the HV transformer. Then all three other things are grounded. That I am going to apply the high voltage, that is depending upon the standards of 4029 will be applied across this one. If it withstands the voltage applied for 1 minute, then we say that the induction motor had withstood the particular voltage which is applied. Then we say that confirm that insulation has the better the properties, or maybe they designed properly. If it fails, or maybe if it cannot withstand the applied voltage for a minute, then we confirm that the design of insulation is improper. Once again, it is sent back to the shop floor for the proper design of insulation, or maybe rectification of insulation as such. The test voltage applied as per the standard and kept for a minute and reduced to 0. While conducting the test, relevant standards and the manufacturer guidelines are taken into account. For every time, that is, whenever you want to conduct any test, the manufacturer guidelines or maybe standards which is given by the relevant Indian standards or the consider for conducting the test. In this test, we are going to apply the AC voltage 1.5 times the rated line-to-line voltage, or sometimes the applied the AC voltage is equal to the 75% of the 2 times the rated voltage plus 1000 volts, 2 times the rated voltage plus the 1000 volts. It's about the high voltage, that in all the times when you apply the high voltage for a minute or so, as per standard, that particular electrical equipment has to withstand without any of the flashover, This is about the high voltage test. Then, after knowing the testing of the induction motor, let us move on to the important aspects that has to be considered in case of induction motor is a maintenance. Once it is installed, up to first 2 years, we will not be facing any of the problem related to the electrical equipment or maybe electrical installation. Once after 2 years, it becomes very difficult to have the proper operation from induction motor. At that time, it's always essential to consider one point, that the maintenance point has to be considered. Maintenance point is to be considered. That's why you say that once the induction motor is properly installed and start working, after some days, it is very important to have the maintenance and the periodic check on the induction motor to get trouble-free operation and to have the high efficiency all the time and to have a long life, that is a long expected life or more life, and to have the highly reliable operation from the induction motor. Therefore, to keep or to have these above objectives, it is always essential to have the proper maintenance as well as the periodic checks of an induction motor. It is to be done in accordance to the standards provided for the particular induction motor, or maybe the highest standard of 4029. During the process of maintenance and the periodic checks, the following should be taken into account. The proper record should be maintained, that is whatever the log sheet, what you call it as, has to be maintained, and this experiment should be conducted with the help of a skill and a technical persons only, and the facilities should be provided properly for the storage of all the electrical equipments required for a particular maintenance. This maintenance includes the following activities to be taken up to keep the machine in working conditions. The following are the activities to be taken up to keep the machine in the working condition. That is, the first one is protection of an exposed surface. That is, all electrical equipment provided with the outside casing. Therefore, it becomes important to have the protection of the exposed surface. Then, the proper insulation level or insulation resistance has to be maintained in both the stator as well as the rotor winding. If it becomes less than the particular specified value, once again we are supposed to go for a drying off on the induction motor, Then afterwards, since at the shaft at end it is provided with the ball bearing as well as the roller bearing. That's why it is always essential to have the proper maintenance of the bearings as well as its lubrication is properly provided. Then afterwards, the slip ring maintenance and the brush maintenance becomes very much important to have the proper attention between the slip ring as well as the brushes. All these are to be considered as the important activities to keep the machine in the good and the proper working condition so that it can provide the highly reliable operation and work properly. Then the other way of the having a maintenance is overhauling. This overhauling is a method of checking. That the other thing is, after maintenance, overhauling is the broad aspect of the maintenance is overhauling. This overhauling is a method of checking, the inspecting, repairing and making the adjustment to keep the induction motor in a good working condition. Not only the maintenance, sometimes we want the induction motor to be overhauled. This overhauling is a method of checking, inspecting, the repairing and making the adjustment to keep the induction motor in a good working condition, to keep the induction motor or maybe any electrical rotating machine in a good condition for its operation. It is overhauling is essential. The general procedure for overhauling of an induction motor as recommended by the manufacturer should be followed. For overhauling, I cannot do it according to my requirement. It has to be followed according to the guidelines which are provided by the standards or maybe manufacturer guidelines. However, the following gives a general guidelines for overhauling of the motor. General guidelines, that is, first one, dismantle the motor without the excessive forces and without the hammer. That is, completely dismantle it part by part without using the excessive force or maybe using the hammers. That is, completely I am going to dismantle it part by part without the excessive force. Don't force the bearing on the shaft by pressing the outer surface to remove the bearing from the shaft. That is, there is the procedure exists for removal of the bearing. I should not use the hammer or maybe any other force to remove the bearings from the shaft. That is, the bearing pullers will be provided. From the bearing puller only that bearing should be removed from the shaft. Otherwise, if the surface gets damaged, unwanted vibrations comes into picture in case of the shaft or maybe when it is assembled. That's why the bearing pullers are a must to remove the bearings from the shaft. Clean every part of induction motor for its dirt, oil using the blower or compressed air and wash with the petrol to which a few drops of the oil is added if necessary. That is, completely all the parts are thoroughly clean for dust particle, oil particles or maybe any other fibrous content by properly using the blowers or maybe any of the solvent that can remove the every dust particle on each and every part, so that all the foreign materials which are accumulated on the inside parts of an induction motor must be removed. Then check all the parts for its damages, repair or replace them if damaged. When it is dismantled, all the parts will be outside and check for its damages, and if they are correct, clean it and assemble it. If they are damaged, then replace them completely with a newer one. Measure the insulation resistance and dry out if necessary until the correct value of INR is obtained. That is, once it is cleaned, the obtained maybe check for insulation resistance of the stator winding as well as rotor winding. If it is less, once again the drying process of a stator and a rotor has to be done. Then after the drying, once again check for its insulation resistance. If it is according to the standards or the correct value, replace it or maybe insert it, assemble it. Repair or replace the winding if they are damaged. That is, if they are damaged, replace them. Once it is replaced, once again insulation resistance must be thoroughly checked, and the procedure of drying is essential if it is less. Then afterwards, revarnish the windings if it is required. If it is not required, completely assemble it. And afterwards check for its connections and try to commission it. Steps involved in the overhauling of an induction motor are: visual inspection is the first, then dismantle it, clean all the parts. That is, these are steps involved. Visual inspection has to be done, dismantle completely induction motor, clean all the parts which are dismantled it thoroughly with chemical solvent wherever it is required. Use the blowers to remove all the foreign particles. Replace all the damaged or maybe worn out components. Components or maybe worn out the components. Impregnate the windings. Check the insulation resistance and dry out if it is necessary. Then after making all the above, reassemble and conduct the tests. Measure the insulation resistance, and if it is the correct value, forget about it. Otherwise, dry out if it is necessary. Afterwards, the commissioning tests are conducted. And once it is all the tests are satisfied, put that particular induction motor into service. This is about the steps involved in overhauling of an induction motor. Then completely what we have seen, it will be in the form of a chart. The activities in the preventive maintenance of an electric motor are this one. DI means daily inspection, weekly inspection, monthly inspection, hourly inspection, as well as yearly inspection. They can see that these are the activities that are to be done in either in a daily, weekly, monthly, half yearly, as well as yearly. Visual inspection, it is done. It is a daily visual inspection. General cleaning and blowing with a dry air, it should be done weekly and monthly. Then check the brush gear and slip ring of an AC motor. It may be done anytime, but it is preferably it is only monthly activity. Then measurement of insulation, it can be checked daily also, but it becomes very difficult. That's why it may be a monthly, or sometimes you can have the scheduling of half yearly only. Check the air gap. It is half yearly activity or maybe yearly activity. Check the tightness of the terminal connection with the bolts. It may be the half yearly, or you can do it for the monthly activity also, or maybe yearly activity also. Check for vibrations. It can be a monthly activity as per the standard, but it can be done even the half yearly also if it is required, depending upon how many number of hours that particular induction motor is operated. The performance test, it can be done half yearly, or maybe if it is a scheduled, unscheduled, you can do it anytime as such. Check the stator, the control gear. It is a yearly process or a yearly activity. The bearing maintenance, once again, it is a yearly activity, or depends upon the number of hours over which the particular induction motor might have operated. Then maintenance of the cooling system, it is a half-yearly activity, and overhauling once in 2 years or maybe once in 5 years. Now these are according to standards. It is a scheduled maintenance. It may be sometimes, it may be unscheduled, depends upon the number of hours over which a particular induction might have operated as such. Sometimes in some industry, the complete induction motor will be operating 24 hours a day into 365 days. At that time, the induction motor will be constantly operating over number of hours. At that time, the unscheduled maintenance may come into picture. Unscheduled maintenance comes into picture. At that time, it is always essential to have the unscheduled maintenance to keep that particular induction motor continuously in operation even after the maintenance. The summary, that is what we have learned today, is a block rotor test, and afterwards we had the topic related to high voltage test. All these tests are conducted to check the ability of an insulation or maybe induction motor, whether or not it can withstand the particular voltage levels applied in according to or maybe in accordance to the standards. Then afterwards, overhauling and maintenance is a very important aspect once it is commissioned to have the proper highly reliable operation and high efficiency, as well as the long life from the particular induction motor. It is always essential to have the overhauling as well as the maintenance. These the maintenance and maybe the overhauling, maybe sometimes scheduled maintenance and scheduled overhauling according to standard. Sometimes it becomes a unscheduled activity also. It may be sometimes the unscheduled. All these topics which are discussed today comes under the level of L1 and L2, that remembering and the understanding. The textbook that I mentioned here, that those things can be referred for the above topics or maybe complete topic of testing and commissioning of electrical or maybe power system, the apparatus. The first textbook is written by S. Rao with this title, and second textbook written by R.L. Chakrasali with this title can be referred for the above topics or the complete topics of the testing and commissioning of power system, the apparatus. Thank you.